So let me summarize what I just said. So we want to create a scheme routine which can be used as a macro from inside TeXmacs. So I put it in my personal initialization file. So we use the same hello macro as discussed before, and here is the definition in scheme. For security reasons, I also put this additional statement inside, so because scheme statements can be insecure. They might, you don't want, if you open a document, that your hard disk is being erased. So this is a way to declare that this cannot happen. And if we go to the overview of the scheme extension language, then you can see an example of how to define external macros. So here you see an example. Apparently here it takes two arguments, the function itself and the macro argument. So this is precisely what we have done here. Where are we? In this document. So let me show the preamble. So we started as before, but instead of doing this, as we saw earlier this week, we're now going to call this external scheme routine. So I can just activate this thing, and as you see, I can just now there is something strange here, because just before this didn't work. I think that still works. Let me check something. I'm going to reload the buffer. I want to check whether the thing can be edited. Now it cannot. And the reason is that there are, as I said before, there are some DRD properties about tags which say which things are accessible and which things are not accessible. So if these DRD properties are automatically associated to macros which are being defined using the TeXmacs macro language. And usually there's a, well, this is done heuristically, but usually this is correct. Of course, we did not analyze this scheme code which is there. There is no way automatically for determining whether the T that we got there, whether this was still a tree which we are allowed to edit. So in order to make this thing editable, we go here and we do something which is, we enter a thing which is called DRD props. Now I again don't remember the exact syntax of these things, so I'm just going to search this in the documentation with some luck. It will tell us how it works. So I'm just going to set the arity of the thing to 1 and to say that everything is accessible. So I can say that hello, that it has arity 1, and that all the children are accessible. Okay, now I go back, and now I think, well, now of course I saved this in the preamble, so maybe that's also a thing which is, I might have, it's better to save the thing in a style package. So, but anyway, so if I now reload the thing is get refreshed in the right way, and you see that I can edit the arguments.
And does it have to be scheme macro? I mean this implementation with this. Yes. So if I in the
Preamble.
in Emacs, no, yes, if I just remove this backtick and comma and make it an ordinary function, will it work?
What do you mean by an ordinary function?
Ordinary scheme function, not scheme macro.
This is not a macro, this is a function. tmdefine is a function.
But then, no, I mean, if I just write the same thing but without this character and this character.
Then it's trying to call the scheme routine concat, which does not exist.
Yes, sure, but then I put this thing before.
When I use a scheme routine, the idea is as follows. When I use a scheme routine in an external way, as using the extern primitive, the semantics is that this scheme routine should take arguments which are all TeXmacs trees, and it should give me back a TM expression. A TM, remember, this was a hybrid expression which was partly a scheme tree and partly a TeXmacs tree. And here, indeed, you see that things were mixed up, right? Because the T that we are giving here, it's a TeXmacs tree. We keep it here as it being a TeXmacs tree, but the thing that we construct here and here, that's a scheme tree. So together, this is the TM type. And so this hybrid kind of TeXmacs scheme trees should be, it's called the content type as well. I call this content type. And if you go to the glue for the C++, every time you see content, this corresponds to this kind of well, mixed TeXmacs and scheme trees. Okay, but now, of course, this is arbitrary. I mean, this is arbitrary content, right? I can now. I mean, you can put something else here. So let's see. I think maybe I think it was this one. And then we can do something like well, this is a tree, right? So we probably want to make a string out of it. And this string, I want to make a number out of it. And then I hope it's going to work. We'll see. So this is just a test for myself. So now I'm going to make, again, a string out of that. Okay. I'll do it like this, actually. Number string. I, and then comma, and then right, that's all. And then I'm going to do number string of k itself. Then we can still put what dot if you like so. Let's try this one. Okay, just to see, to show that of course we can really use scheme inside, right? It's not so here typically of course we wouldn't assign some DRD property because in this particular case of course the thing is not going to be editable a priori. Oh, we might make it actually. We might make it editable. Don't forget that. We might make it editable, right? We put... I'm not sure whether this is going to work, but we may try. We may try. Okay. We'll see what is happening when we do this. Maybe we get some ugly crash. We'll see.
Where do you assign the preamble? Can't you just use the external interface?
Huh?
Can't you just use directly the external command inside the document instead of? It seems you have a duplicate definition. You have in the preamble you have the assign and then the external inside. You could use
Yeah, we could use different names.
yeah, we could use different names, or we could use directly in the document.
A function. Yeah. You as you saw in the help just before, right? We are in the
So, yes,
where was it? Where was it?
What's the reason for wrapping it?
Well, I can TM define a big routine here. I'm not going to define a big routine in my TeXmacs header. I mean, I would like to usually, if I really have some functionality which I couldn't write in a macro, I usually want to edit this in some scheme file. And
But then it will be portable. How to communicate this back to somebody?
So yeah, you will have to communicate both the style file and the scheme file. That's true.
No, but I don't know if I understood what you meant, but actually wouldn't it be possible to have this imported in a more automatic way than having to do an assign explicitly? The definition that you made in the scheme.
You mean the extern?
Yes.
Yeah, just to use external in the document. Is it possible?
Oh yes, that you can do. That you may, of course, sure. Where were we? Yeah, I can do extern count 5. That's okay, no problem.
Without macro.
That's okay.
Okay.
But usually you're defining some kind of new markup element in this way, and then you put it.
If you would like to bypass altogether all the styles, all you would have to do is to define something that works like the slash as a escape mechanism for accessing external things in a shorter way, or a key binding. You would have direct access to scheme and would forget completely about this intermediate limit.
Yeah. And this is, by the way, something that we actually might want to do. So basically, we might imagine it wouldn't be very hard to do actually, but it would take a few days of thought and of implementation just to make style files in such a way that we could directly define new scheme functions from within the style files themselves. But then, of course, this has to collaborate somehow with the scheme module system, right? And also, if some style file depends on some other style file, it has to be made clear who depends on who. It also has to be made clear what to do with the security issues. So basically, then this security issue comes back in a way which is much worse. We really need some simple mechanism for declaring, well, from which sources we are going to accept style files and when things are going to be declared to be secure and so on. Okay, so it's doable, but it requires still some work to do it. But it would be nice. It would be nice.
Maybe it's really better to keep executable things and pure document things in separate files, not to mix them.
Maybe, but I can also understand that some people would just like to have one central style file with everything inside, which they can send to someone, and then that everything is inside.
This thinking is what led to Microsoft Word viruses, for example.
Right.
Will you show the macro again, please? But it's supposed to happen to end, I guess, it was a tree.
Yeah, yes, but I didn't declare this time the end to be. I didn't declare this end to be editable. Yeah, it's here I called it by the extern primitive. So the extern primitive, it assumes that all the arguments are not editable directly. So I cannot put my cursor on the 5. On the other hand, if I go back to this one here, I did declare it to be editable. So I can put my cursor there and just start editing this thing. Right? Nothing wrong with that. I can do that.
How do you manage to, how do you get it to the 10 and get all the way to the 20?
Well, this part of the expression, just the tiny part, the last argument, this one, that was editable, right? Everything before it's not, right? Everything before I cannot edit. But this part, I declared it to be editable. And since I passed it as a tree here, the trees know of their position. If you declare something to be editable, of course you have to make sure that the thing also occurs in the final document, right? So if I would not put n here, but if I would put k here, or I mean number to string of k, then we would have a problem because I mean the k is not part of the document, so TeXmacs would search for the editable argument, but wouldn't be able to find it anywhere anymore. It's not in the result in that case, but if it's in the result, and here the n was in the argument and it's again in the result, so that's fine. So I may declare it to be editable, and I can position my cursor just inside and start editing. No problem.
And what if n occurs 2 times in the result?
Huh?
What if n will occur twice in the result? N dot and n once more, for example. Counting to n.
Okay.
Edit all of them, and the result will be.
I can only edit one.
Really?
and it's traversed twice, as you see here. When I go here, I'm going right with the cursor. I'm left with the cursor here. Now I'm going right, to the 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 right, and then I'm to the right. Now I'm going back left, and it's going to do this. This is not perfect. It's not perfect, but okay, it's a bit a strange macro anyway, right? But okay, this can be improved. I thought about improving this kind of thing, but
you show me again the preamble. Can you show me the preamble again? I missed how the count accessible.
I just say that all the arguments of count are accessible.
And how you declare the second argument, for example, accessible? Just accessible to?
Yeah.
Okay. And if you want to make accessible a subset?
You just say accessible 1, accessible 3, accessible 7. Right. Okay, so this about macros, right? So, well, you can play with this.
So when you call, when you call it, it marks the trees as arguments. It numbers the tree. How it can recall what is argument 1, argument 2? Because you pass to
all the trees know where they are. A TeXmacs tree, even in
no, yes, but how it recall that it was the first argument?
Let me give you one more thing.
No, this I understand. I don't understand how they can be recorded.
I would just like to show you what I claim here. So basically, just want to show this, that these are really TeXmacs trees. And these TeXmacs trees are full TeXmacs trees, right? Don't forget this. So I'm going to take this thing. So I have a position here, right?
Yeah.
Now, actually, I might even do something with the parent of this tree. Okay? I hear usually you're going to do something with the arguments, but
okay, this was the position before the modification, actually. No.
Well, if I modify the thing,
Yes, but
this is the new position of the thing, right?
But no, I mean it's not correct. It's not at that position. It's
Oh, it is. Now it is this is at the position what is being said here.
1, 5, 1, 0. But
This means, what does it mean? One is the document itself.
Okay.
5, it means 0, 1, 2, 3. Well, we have 5. It's number 5. I don't know why 5 and not 4, but 0, 2, 3, 4. Oh, there's a preamble. The preamble counts for 0.
Okay.
Okay, so we have, I guess, or something like that. Yeah, but there's a tag around it saying preamble with lots of lines. Okay, that's 5. This is a concat.
Yeah.
So this is the first 3 letters go into 0, and this macro application goes into 1.
Yeah.
And then we go in the argument number 0. So that's the argument being 0. That was the location. That was the location of that was n.
That's what I said.
That
the
was
location
n.
Before the.
At the moment of the typesetting. This was because this routine count is being called at the moment of the typesetting.
Okay.
So this was exactly when at the point that I start to typeset. That was the location. Yeah. Okay. So and this is a tree. So I can actually I have the full tree language at my disposal for implementing this macro.
Can you display the location after the step setting? I mean, because
It's the
new
same.
location,
The
no,
typesetting does never
mean-
change it's not assumed to change the document.
but the document is
So
different.
it's a location of the.
I mean,
No.
the current location of
The document doesn't change.
write the location of the cursor. Output the location of the cursor. Now, I mean, it's not the one you.
Yeah, but it's but I'm not outputting the location of the cursor. I'm outputting the location of the argument n.
Before the application of the function, but then the function changes the tree and the.
It does not change the tree. This function is rewriting the tree into something which is going to be typeset. It's not modifying the tree itself.
Okay, I understand. Okay, so the document tree is the same. This is no.
This routine, by the way,
So only
if
the boxes.
I may, in this routine, I am allowed to navigate into the thing. I might, for instance, look if I'm inside the theorem. Maybe I might, for instance, I might check whether I'm inside the theorem and display it in the thing in red. And if I'm not inside the theorem, print it in blue. Let's try to do that, right? Okay? So I think that's called inside. This is maybe not the best way to do things, right? But or maybe tree inside. Yeah, tree inside. Okay. So for instance, cursor tree. Is it inside? Let's say a session. No. Or inside maybe, don't remember, or inside session. I don't remember the, yeah, okay, tree inside, I don't remember. I don't remember the syntax. Tree inside, maybe like this. Or now, well, okay, I will just re-implement this thing. Doesn't really matter. Let's just make a t and define, let's say, in theorem. Theorem t. So if we are a buffer tree, then this is false. If we are a theorem, then this is true. And otherwise, it's in theorem tree up t. Right. Okay. So now I'm going to do with color with color in theorem n. So if the thing is like this, red, and otherwise black. Okay. And then this one I'm going to put with color n. Okay. We'll see. Not sure that this is going to work out of the box, but we can try. Oh, what happened? Oh gee, something is wrong. Buffer tree. Oh, tree is buffer maybe. Tree is buffer. Let's try this one. Don't remember. what does it say? Ah. Let me see. Buffer tree buffer maybe. Buffer tree is buffer. Oh, tree is buffer. But I did the, oh yeah, of course I should ask T. Okay. Oh gee, what's this? It's variable color. Huh?
Should not.
Oh, maybe I should put this like that.
The first column shouldn't be
This.
the first one.
Yeah, well, you see all these dollar things have a particular...
Below the secure, shouldn't you use quotes or column?
No, because this is just a function.
This is a declare variable in the string.
So I'm sorry, these things are a bit tricky, but this will work at the end, but I have to I'm going to do it differently. Because I don't know how to do it, but I guess that this will work simply. I hope so, at least. Yeah, so this is a bit, and then I hope this is going to work. Right, good. So now we take this thing. 50. That's a more reasonable amount of. Oh fuck. So, okay. And that's just, well, because you can really navigate in the trees. Okay, so maybe this is actually the way to, this is maybe the way to implement CSS, by the way. A proper way to do it. Now that I think about it, but okay, this is in principle
to emulate CSS.
Right.
To emulate.
Right. Yeah. Right. But in any case, what you shouldn't do, of course, is modify trees, because this basically is rendering trees, right? This count macro may do many things. It may analyze my tree. It may do many things, but it shouldn't modify trees. If you start modifying the arguments, well, I don't know what's going to happen, but I fear it's going to be bad. Okay? Right. Okay, so this about macro definition. So we were also, maybe with half an hour still left, we can do equation array. So, yeah, that will be tomorrow, I guess. We will first do the easy part, right? Which is going from the equation array to an equation.
And leave the other for equation.
Okay, so we definitely want some keyboard shortcut for doing this. So what will it be? Well, no, keep going. Control F10, for instance. I'm not sure. What can we use as a keyboard shortcut for this? Control semicolon. Don't know if I use this.
What about using the shortcut for building an equation array when you're inside an equation? That would require in equation, then when you press equation array, then it switches. That would be cool.
So you say inside. No, more, I'm sorry. Require. Yeah, but if I put in math here, it should. Well, there are inline equations, outline equations. I'm not sure. Inside. Well, okay. Inside equation like that. Okay. You do it like this, and then I think it's meta this one, right? If I'm right. On my machine, I hope this is. Oh no, I should be into an equal array stuff. No, wait a minute. It will be dollar, just simply. Okay. Let's say. Okay, whatever. So the first thing we're going to do is to take the tree, which was the equation array. So we just collect the equation array. Then, well, I have to go to the body of my table.
Can you explain a bit more of this with innermost equation array? So where does the equation?
Okay.
So if the tree has an innermost equation array collects it, or
Let me show. Okay. Let's say save. And now, what does it do? I press this thing. Already inside mathematics. Yeah. The point again. My keyboard shortcut got overridden by somebody else. Okay. So that's why I wanted to take a different keyboard shortcut, which is which I hope to be sure that nobody uses it. So I don't know, Control $, for instance. Let's use Control $, for switching.
is there a way to ensure that if you really want to use dollar?
Yeah. So if inside math mode you want to use $, just do $tab.
No. If you just want to use dollar for your keyboard, which you say you will type.
Yeah, well, the way is that all the last one who redefines wins, and so you should make sure then that you are the last to override. So maybe, for instance, delay the moment that your keyboard shortcuts are going to be applied, for instance, by putting in some delay for to write some new function of something which is going to be loaded, but only loaded after all the other functions, for instance. And then, but usually, if you are really writing your own plugin, for instance, or if you're reading your own or really hacking the TeXmacs sources, then this is easy to do, because you will just do a use module of everybody who will define this thing before you, or at least those ones who do it before you that you want to override. Okay. Okay. So let's go to equation demo, and so now backslash control thing, and here you see it. Okay, so this is just with innermost, just it's going from the cursor position outwards, and it's going to search for the first tree whose tag is equation array star. And here you see it. You also see how it is like. So there's a T format inside, there's a table inside, and then rows inside, and then cells inside. So this is the way it's presented. That's useful for us because we now want to take basically all the cells together, put all this stuff in a concat, and just replace the whole thing by that. Okay. So now actually there's a nice way of doing that. We have, now that I think about it, well, of course I can do this in the dirtiest way, just by doing tree ref. Okay, I can just do, for instance, if tree is T format, I can do set, I replace the tree by tree ref. The format can, for instance, specify some background colors or things like that. And if you look at the syntax of T format, it's the last argument which is going to be important. Okay, so I'm going to replace the T, if it was a tree. Oh, of course, already the equation array itself, I'm going to replace it by basically by its first argument, right? And then this first argument might be a T format, might actually also not be a T format, but if it's a T format, if someone got colored, then I just want to take the genuine body, which is here. No, I'm not modifying. I'm just modifying the variable which points to the tree. Modifying the tree would be tree set. This would modify really inside the document my tree. If I just do set, it just means that the variable which T, which contains my tree, which points to my tree, I'm just modifying this variable. That's okay. Okay, and then at this point where my cursor is now here, my T should contain a table with rows and cells. Okay. Now, of course, I may try to collect these things just by going through all the stuff, right, with tree ref and map and whatever, right? I may do that, but maybe a nicer way would be to say we're going to select. Okay, we saw this thing already before. You remember this talk I gave a few days ago? We used this keyword. Let me try to find this talk back. Where was it? Was it here? I don't remember. We'll see. Yeah, so that was there, right? That's the right one. Here, you remember that I selected in the buffer tree, I selected some subtrees, all subtrees of the form granite. Okay, I did it this way. Okay, I can do this again, right? And here, this just means that on the path I'm allowed to put anything, and as many times as needed. Okay, So why not just do this? Just take the tree and select all cells. Okay. Now I'm a little bit worried about doing this, things like this, because of course what might happen is that inside my cells I have other tables. So I'm not sure if I do this that there are still some matrices, a matrix for instance somewhere inside, and that I'm going to select those two. So I have to be a bit careful probably. So maybe a better way to do things. But I know that I'm expecting a T format, and then a table, and then a row, and then a cell. So I may also do things like that. Okay? I'm specifying a path of things.
But will be the same for the matrix inside or for any...
No, because I'm doing it only once. I didn't put the star this time.
Okay.
Okay? So I do it once and not more. Okay. So this is probably the easiest way to go on. And if I do it at this stage, I also have to select. No, I don't know. We'll see. Let's try. Let's just try, right? Let's just try. Just take this thing and let's just try. So I get my equation demo back. Let's see. And I'm pressing. Oh, didn't work. Well, maybe I should have put an array star. Let's try. Still doesn't work. Let me try that at least if I put things in this way that it does work. Yeah, that worked. Okay, great. So let me then just go back and let me test whether I can do it this. Maybe I didn't use the right syntax, right? So I usually forget myself about what I did myself, right? I mean, this select statement was programmed, I think, 10 years ago, so I forgot about it. So the fastest way for myself is basically just to try again. This works. Okay, so I assume that definitely I could have done this, and that this should also work. This still works, right? So there's just one thing of how, the question is how to start, right? What was T already? I think we had this one. T was equine arrays. Oh, of course. There was a document tag. This macro was a multi-paragraph tag. So there was an implement document tag inside, which was not even printed. You didn't explicitly see it, right? So so you see these document concat tags are tricky, okay? But okay, that's the way life is. And now we're done. Okay, it's okay. Good. So now I think, if my memory is right, that I even have a predicate for testing whether a cell is empty. Do I need that? Maybe not even. Maybe my simplification routine will just already take it away. So let's try now. Now I don't remember how my simplification routines worked, but tm concat, I'm not even sure anymore whether tm concat, whether this was a function or a macro. If it was a function, then I can just apply it. So let me follow the suggestion by, who was it, and just search. Who taught me, who made me aware of the fact that I could search in the source code? You made me aware. Thank you. So I'm going to do exactly that, and that was tm concat, right? That we wanted to search. Then that's defined there. That's great, and that was a tm define, so that's perfect. So we can just apply this. So basically, I'm just going to apply this thing. And then, of course, I now have to say tree set this time. Okay, so this is not anymore the one from before. This is the one which really is going to modify the document. And now we are going to put an equation there. Oh.
You want exclamation point?
An equation. I don't remember whether I have to put a document here. We can do it. I'm not sure. Maybe not. Well, let's just try without. We'll see what happens. And, well, I definitely have to put a concat. No, I'm going to do tm concat, right? I'm going to do, and I'm going to map tm concat to L. And I'm just going to do all this.
This way you maintain the cell statement or not?
Huh?
You have the cell statement, the cell tags.
Oh, terrible, you're right. So, we are going to do, I think I can do 0. That just takes the argument number 0. This is a selector, okay? Select selects. So basically, if I specify the name of a tag, it's going to select all the tags with that name. If I specify 0, it will just take the argument number 0. If I specify something which is called like this, I think it's this one, then this just means anything but just one. If I specify this, it means anything and any time you want. Okay? But you have to read the documentation of the select tag, and you will find it there. And this is also the way that tree ref works. Doing tree ref and doing select and things like that are often quite similar. You can also go to a next argument or go to a previous argument. You can navigate in the tree with select even. Okay? So, so let's see. Is this going to work? Huh. Well, something went wrong. Oh, and now we got a segmentation fault almost.
You have the equal with the empty shells. Empty cell. The third, you see the third, the tree is empty. It's a bit weird.
Huh? What is empty?
The third tree.
The?
Third tree.
Third tree. The third.
This one. This you mean?
Mm-hmm. I don't know.
But that should be okay. I mean, if tm concat really eliminates the bad guys, but I'm not sure anymore. Let me do something. I'm not sure now that I see this, that tm concat is right. Maybe I made an error in the implementation of tm concat itself. So let me just do one thing. which is map tree to S3 of L. So as to be sure that I'm going just to check it for something simpler. If I did it well, for this thing it should work.
Yeah, I think that's the problem. It really is looking for the empty string.
Exactly. So if it looked for the empty string and not for the empty tree, then we were dead, right? So let's see. Well, now something also went wrong. Oh, what's this?
You want to know this?
Yeah, I went to another screen, but I want to go back. How can I go back?
Go up. I think if you insist to go up.
Yeah, good. Oh, concat. Oh, TM concat. What does it do? This is strange. It doesn't create me a concat. So where was it already? TM concat. Let me check.
But not TM concat. You should have one TM concat applied to this list of arguments, don't you?
Yeah.
It's not, you should map.
Well, oh, I did map. It's not map, but this is ridiculous. It's apply, of course. It's apply, right. That's it.
Then the first person might have been right.
It might. We'll see. We'll see. Let's see. Yeah. But I'm making lots of errors, right? So you will have to help me a bit.
Yeah.
That's it. Okay.
Come on, hello.
Right.
But you cannot go back. Okay, you can go back.
I can go back.
So it was also it
Okay. So actually it was equation star, by the way, right? Okay. So now we can basically also check with the L. Let's see. Yeah, that's what I was going.
There was a problem which, what was the...
I definitely want to check this.
There was a problem.
Let's check.
Okay.
Let's just try. Works better. And you see why? Because my cursor is still at the right place. I don't know how this occurred, basically. Let me try again.
Probably does it traverse
No.
the tree?
This is not systematic.
No, because I mean.
And I actually can say where to go. If I do tree set, I can do, because that's often another problem when you're doing these kinds of operations, that suddenly your cursor moves it to a place where you didn't expect it to be at all. So typically here we expect the cursor. Sorry. Numéro masqué. Yeah, I'm not going to reply. Tree go to T0 end. This is just going to go inside the argument 0, okay, which was the concat or whatever, and to the end of that. Then it becomes at least something which is more or less predictable. So let me put the cursor somewhere, and okay, it's predictable now. Okay. Right. So that's nice. So.
I'm gonna delete this line with B special.
Right. Yeah. We can remove this one, right? Okay. So that's the routine. Now we want to go back. So this is going to be bad
Painful.
and
No, it's
painful. No, it's much harder because we now have to find all the occurrences of equal. And not just of equal, but all binary relations. Okay? So we have to search. We already have to know the list of all binary relations. How do we get them?
You don't want all binary relations.
Oh, I want. Sure. Definitely, I do. If I have some
No, okay,
A
you
less
want a
than-
limited set because maybe other binary relation are used for another. Either you can pass semantically or you don't understand.
I don't know. Let's see what the binary relations are. And let's see whether we want them or not, right? Huh? So,
It's a
You want a comparison relation.
No, he wants to show us the parsing.
so we have something with all the symbols, and we have something with all the uh, all the um, all the binary relations somewhere. So I will just search. So let's search for less, for instance. That's a binary relation. So here they are. Relation no lim simp. So do we want all these? Well, I guess we want most of those actually. Maybe not all of them, but most of them we definitely want them. Phew. So do we have some way of getting this? I don't know. So we have 5 minutes left, and maybe I'm not going to try to do that. Right?
Why don't you just define some binary relation and fill it with some default values?
But well, what I can do, of course, is just there is a nice feature even in Emacs which is called copy and paste, and it's not ideal here. Right. So here we have the list of binary relations that we want to check for. And, okay. Let's see, do the pair. Yeah, that matches. Right, okay, good. But now starts another bad part, which is writing this routine. And so we will really need to go through this time the whole, yeah, all the concats and all the strings in the concat. And well, the other problem is that we have to tokenize the strings, because the strings are not just strings that you can go through character by character, because TeXmacs characters are not characters in strings.
If it's written x less than
Right.
y, then they are in the same string.
So we need to have the right way of decomposing strings into lists of characters and to put them together again, right? So let's see. I guess that is a more common situation, and I probably took care of that at a low level. So I guess that this is going to be implemented somewhere in the glue, right? So where is this going to be? Well, there are routines for strings here. So that's definitely somewhere where to look. Oh, look at this. routines for strings in the TeXmacs encoding. That's nice. TM string we have there. And we can go from the usual, from some encoding to the TeXmacs encoding. We can get the number of elements in the TeXmacs string. We can get the thing at a certain position. We can make a list out of it. And we can go to the next character in a string. We can go to the previous character in a string. That's nice. We will just use TM string to list. That will do for us, right?
You cannot parse semantically the mathematics to extract the binary relations instead of doing that.
Yeah, that's the background parsing.
Yeah, but I can do that. But how is it going to extract it? Is it going to extract these things exactly in the format that we want here? For instance, if I ask the parser, maybe I would, if I write, for instance, f of x equal y, maybe the equal in the parentheses will also be passed or so. I don't know. I mean, I'm a bit...
But how you
parsing is doing something a bit different, right? It's going to give a semantic parse tree associated.
No, imagine that you have a summation string somewhere. I equal sum I equals 0 to 10.
Yeah.
How do you recognize from the string that this is not unequal between two?
Well, because it's inside some other markup. It's inside the subscript, and we're not going to have it. Yeah? What is the representation of sum of I equal 1 to 10? It's and then something else. You're going to have a concat.
Yeah.
Then you're going to have maybe a big sum, and then you're going to have a subscript of something. But we are only interested in the strings which are at level 0, really inside the concat itself.
For me, okay, but I suspect that to recognize what is level 0, what is not level 0, you need...
Let's start writing the thing, right? Because okay, so we definitely are going to start with doing this here. And the first thing now that I think about it that I would typically do for this is just decompose everything in singletons. So I would really like to have a list of everything which is just inside this concat, and in the list I either want to have markup elements or strings of just one character. Okay? So let's try to do that. So let's say concat decompose. Or atom decompose. So here we give it 3. So if tree atomic, then I will take the TM string to a list of the tree to the string, make a string of it. This is a string, and otherwise I will just give the list of T itself. Okay, and then concat decompose will do the following. If well, there are several cases. If the thing is atomic, then I will just do exactly what I did there. So that's atom decompose of T. If tree is a concat, right, then I'm going to apply append to map of atom decompose to the children of this tree. Okay, so I'm going to decompose each of the children. Each of the children will induce a list. I will just append all these lists together. And otherwise, again, I'm just going to return list with t. Okay, so let us check that this is going to work. So we're going to make a new keyword map. Equation array, and then I just want to display for the moment. I just want to know whether my thing is going to work. I want to display this list. Concat decompose. So this is not t itself, but it's this one. Right? Let's see. Well, the first one is going to work. I save this one. Now, let's see. Hey, I'm not inside an equation star. What's going on? Equation star, equation to equine array. Did I just did something stupid here?
No, with inner not equation. You need to have equations.
Oh, equations. Right. So I did do something stupid then. Right. Good. So here we definitely got a list with the separate items, which is nice. Let's try with this one. That's okay. Let's now try. Let's try this one. Okay, this didn't work. Atomic decompose. It was atom decompose, sorry. Okay. You should have noticed this. You're sleeping now. Okay. So, right. So this is okay, right? So now we did decompose all these things. And now, if my memory is right, there is a way to split. Yeah, sure.
C plus the tree, or is it?
A, Lexland, B equal C plus a big 3 equal D. Right. So now I think that in the if my memory is right, there must be some in the kernel. This is basically in kernel library for lists. So this is basically things which come from the SFRI, which is in the schemes standard, but we don't use the SFRI. We really don't use much about scheme. So actually we could even re-implement scheme ourselves if we really would like to do that. But we copied a few routines from. So there is something here, for instance. Look at this one. List break. So break a list at the first element satisfying something. That's not the one. List scatter. Break L in a list of subsets at points which satisfy some predicate. That's nice. And then we have an additional argument which says, do we want to keep the thing or not? Okay? So right, that's nice. So we have this routine. We're going to use that routine. So okay, so we already have a first list, which is the one that we just made. Then we're going to make a second list, which is list scatter. I think, what was it? List predicate. So this is just, I guess, in. No. So that's L1. Yeah, right. And well, we'll make a predicate out of this. I'll make a predicate. Okay. And we want to keep.
No, you don't want to.
Yeah, we want to keep the equation and the unequation, the signs there. We want to have them. Sure.
Yeah, but okay, you can push out.
We definitely want to keep them in this case. Let's see.
True will work as a predicate.
Oh, I see. So that way you can
Sure.
keep the last time or equal.
No, I mean it's not allowed, so we will call true with the other.
Position A. 90. Where's 90?
I don't think you can have true as a predicate. It's better apply the approach.
It was not a predicate. It was just.
But I think it will give you a problem now. Or like
90. 90. Wasn't it a tree? Wait a minute. Here? Let me see. I'm going back to list. So we had the predicate. Because we did keep here. It's just a proposition, right? A Boolean here. Yeah. This is just a Boolean, but now pred, that's really a predicate. So I don't understand why binary relation. Well, let's just do. Let's just return false here, and let us try to see what is going on here. Display TST. I don't understand this. That should be a list, but it was a list because it came from concat decompose. Came from concat decompose, so that should work, right? Yeah, so we got it. Now. tree, then tree string should have worked.
What's
Tree.
this A in the first line? T equal A. This A is not a tree, maybe.
It's a binary relation.
It's not
It's
a-
testing a tree.
Wasn't it a tree? Oh, I did tree string here. Right, it was a string, right?
It's a string. It's not a tree.
It's not a tree. Good. But that's then easier. Then we can just test whether it's a string. I hope that we systematically did that. Atom decompose, yeah, it should work. Okay, so then we can just test whether, but then we can just test whether it's in the list. Don't need anything else. Up. Okay, that's nicer actually. Let's see. Great. So here we have the result. Okay. So now there are many things that we want to do, because we now want to understand. Yeah. So now we have to be careful, right? We first want to check that there is already a binary relation somewhere. If there's no binary relation, then yeah, what point somehow in applying this routine? So
Just checking length.
that's just checking length. So we are going to say we're just only going to do something if the length of L2 is at least 2.
PDF, if it's not neat.
Yeah.
It's more.
Okay. And otherwise, the number of rows definitely is going to be the length of the thing minus 1. Okay, so let us start to create. Yeah, so how are we going to proceed now? We might maybe rewrite.
Probably even greater than 2, not greater than 1.
Yeah, equal.
Because just 2 sides of this equation we don't do it.
Yeah, we still want to. We still would like to break it in that case into 3 columns.
Yes.
We might want to break it into 3 columns, right?
Ah.
And put some more space.
Yes.
Yeah. So now the question is, what are we going to do? Map. Well, I'm just going to try to do something like make row map of this thing to.
Does not exist.
Yeah, it doesn't exist yet, but
The first row is somewhat special.
Yeah, that's the point.
We put 2 things to
Right.
the first row and just 1 thing to. So I don't know.
You know what I'm.
Sequence fixes many equations as elements of the list.
No, you need to scatter. You need to. I don't know. You need to create. Maybe better. You need to create the row inside the list. Make already the right shape and then you apply them.
Insert entities.
I'm going to make a list of lists, right? Let me do the first one. With L3, we're going to make a cons of so what's it going to be? We're going to make a list of the car of L2, and we might actually already want to apply tm concat to this one.
Or you can put the first one, the
Then
first slot from the rest of the list. Just put the car in the first symbol.
what about this?
And then go to the next row.
You cannot be uniform. I mean, this
Well,
procedure which you
yes,
showed
yeah.
by going carriage.
The first two are different. But from the third onwards, it's the same.
Yeah.
It's the same pattern.
No, you can construct. So you remove this step. You construct the list and then you put the steps at the end in the right position.
Well, you can do that too.
So that
We take the first two and the third onwards. And because they're empty.
What about this? That looks already pretty good.
but
You probably need empty strings.
Now I just have to insert the row in the cell and all those tags, right?
Is the from the second element to the list onwards are they empty after?
Oh,
there is not. You cannot do this because the first line should be in its representation. The first line is represented differently.
let's see.
I mean, the first line has three elements in the other they have two elements.
Or you can just insert empty characters.
Is that not correct? I mean, the second sublist has two elements, no? Or not? Show me the code again. I mean, show me the code. Why it's meant to be carrot then? In the second scene. The water carrot.
Well, let's just try. No. try. Right. Good. That's what we wanted, right? Okay, good. Huh? You want to put the matrix inside?
Put it in TeXmacs.
It's not correct because how do you understand when it's on a single line, the equal between the B and the C?
Oh, that's okay.
So it should work also if you do it, for
You see
example.
here, A equals.
This is the way binary relations work. This is the way the syntax binary relations are in common mathematics being understood. That basically if you put A binary relation B binary relation C, it means A binary relation B and B binary relation C.
Here it can be understood that A equals C plus alpha over beta and not B equals C plus
No way.
alpha over beta.
Who would understand?
You see?
No. That's not
Because
common mathematical.
The spacing. Because the equal just under the left operator, so.
This is understood as B equal to C plus alpha over beta. I mean, for me, it's like this. If you take a standard textbook, usually it's used this
Everybody
way.
uses like this.
Yeah, I think so.
When you do sequence of inequalities, at some point you have an inequality, then you can have inequalities, and they will be always
It's
inequality.
just two sides.
So this is inequality between A is less than C plus
It will do what we said before. We may have something with it.
The one I talked with A is less equal. The meaning of this is that imagine you are bounding some quantity. So you say A is equal to less than B.
Oh, you're
B
right.
is equal to the quantity
Why
below.
was that?
I would do a space to move the equal after
Right.
I would never write it.
But I don't know why.
You're not supposed to write
Here.
this. I write this all the time, but I know you're not supposed to write this. It's not.
Oh, but wait
I
a
know
minute.
it's
Now
not supposed
I'm
No,
confused.
because
It's not.
I will
I
tell you
understand
also.
because I write it, but it's
No, but
not supposed to be written
Think,
like
think
that.
Oh,
about-
there's a
I had it
document
probably
tag
in many
inside.
articles.
I guess that there's a document
You are
tag
bounding
inside.
this quantity by something else and you simplify. So if you put less equal, you lose
Let
one
me check.
information.
Of course.
It's the information that this quantity is equal to the other. You are not bounding again.
Yeah, you don't have to explain to me because
No, but-
I will write this too, but I know it's not. It's not.
No, but
really.
I'm claiming that this is the right way and the others lose information. It's
No.
the information that the two quantities on the right are equal and not just bounding.
And it's the standard convention.
I mean,
And
it's
so
the convention.
you really wanted A to be.
If it's not the standard one, it's the right one. I mean, it's the most useful one, the one that retains more
But you're
information.
not even supposed to.
Okay, so there's one quirk still in our thing, and that was that in the equation star, it also assumed a implicit document tag. So here I removed that implicit document tag, and when implementing the routine, I didn't accept the one which doesn't have a document tag. So basically, I still have a minor problem, and that is that I really should have put a document tag here. Okay, and that I really should have done this twice. Okay. And I will, before going back, I will save this thing in the present form, not to mess things up. Let me go back. And then, that was because Andre very correctly wanted to know what happened on this one, that I now entered and this is okay. And if I do that, it's also doing something, okay? Which is good, basically. And one might also question oneself what happens if I make an error and I enter something like that, but it works. Okay. But if I do this, this is okay, and if I do this, it doesn't do anything. But that was what we wanted.
Copy which